last week we talked about a couple of different types of problems, but one thing we talked about was word problems that had proportions in them. And actually, more specifically, we were talking about word problems that had percents in them. Do you guys remember the formula we used last week to do those word problems? The formula that we used was the percent divided by 100 equals some number of something out of the total. You don't need to write this down right now, but it's actually in your notes already. You have it on that yellow sheet of paper from last week. But we called this equation right here a proportion. And we can use proportions to solve lots of different types of problems. We were using it for percent problems last week. We can use it for some other problems that we're going to see this week. But before we get into those, we're going to start talking specifically about what a proportion is. And to do that, we first need to know what a ratio is. Can anybody give me an example of how we might use a ratio? So if we're talking about a ratio, we're talking about comparing two things. So one example of using a ratio would be like comparing the number of boys and the number of girls. So in this classroom, how many boys are there?
25 or 13.
An example of a ratio would be 12 boys for every 6 girls. All right, that would be an example of a ratio. Now, we are not going to write ratios like this. And again, you don't have to write this down. This isn't the definition yet that you want to write down. We're actually going to write ratios in a different way that's going to be a little more useful. Instead of writing 12 boys to 6 girls like this, we could write it another way. Anybody know how else we could write it? As a...
12.6.
No? What kind of number could we write it as? A fraction. So we could write it as 12 boys over 6 girls. By writing it like a fraction like this, what can I do with this fraction 12 over 6?
You can divide.
I can reduce it, right? We wouldn't say divide, but we would say reduce it. So we can reduce that to
Can't you make it?
reduce by 6? 12 divided by 6 is 2. 6 divided by 6 is 1. So this ratio 2 over 1 is another way of saying how many boys there are for however many girls there are. For every 2 boys, there's 1 girl. All right, now, would we change a ratio like this to just 2? Would it make sense to say the ratio is 2? No. This is actually kind of like slope. Slope is a ratio. You guys remember slope? Rise over run. And remember when we wrote slope, we always did a number over another number. Even if it was something like this, we kept the 1 under there. The reason is it's a ratio, and we want to know both parts of the ratio. In this case, we want the 1 there to show that for every 2 boys, there's 1 girl. All right, so a ratio is a comparison of 2 things that we might measure. So we might count how many people there are. We might count how much something weighs. So in one of the examples we did last week, we were looking at how much copper and how much nickel was in a coin. We could measure the ratio of copper to nickel, and we would be doing that by how much they weigh. So a ratio is a comparison of 2 quantities. Quantities would be measuring something using a fraction. All right, so when we're talking about quantities, we're talking about how much of something there is. Not just the number, but also what it is that we're counting or measuring. The other thing that we need to know is what a proportion is. So I'm going to throw this formula back on here. You don't need to write it down. But it was the percent out of 100 equals the number out of the total. And if we look carefully at this, if we look just at, say, this right here, the percent and the 100 are both numbers, right? And the number here and the total, this is how many of something there is, and this is the count of how many total of something there is. So what is this right here? We have 2 numbers that we're comparing using a fraction, so it's a ratio. We just wrote that down, right? A ratio is comparison of 2 quantities using a fraction. So this is a ratio, and this is a ratio, and between those 2 ratios we have an equal sign, and this is what we call a proportion. It's a ratio equal to another ratio, so a proportion is just when 2 ratios are equal to each other. a common use for using proportions, among many other uses, would be when we're cooking. Let's say we have a recipe, and that recipe calls for 3 eggs for every 2 cups of flour. All right, but let's also say that this recipe only makes enough food for 4 people, but we want enough for 8 people. So we need twice as much food, right? So if we do that, instead of using 3 eggs and 2 cups of flour, we would use 6 eggs and 4 cups of flour. Now, I think this is a proportion. Who can tell me why this is a proportion, which is 2 ratios that are equal to each other? Why are these equal? How do I know they're equal?
Because you can divide them by each other.
How would I show that this fraction right here is the same as this fraction right here? Yeah, well, we could reduce it, right? So we could take the 6 over 4 here, and we could reduce it by 2. And 6 divided by 2 is?
3.
4 divided by 2 is? 2. And we can see that if we simplify both of them, they're the same.
Yeah.
So these 2 ratios are equal to each other. So what it's saying is for the amount of eggs that we have the same amount of flour, even though this one has twice as much of each. So we can write them as a fraction and reduce it and see that those fractions are the same. So this is something that's going to be important like when you're cooking. If you need 3 eggs for every 2 cups of flour, you don't want to say use 10 eggs and 40 cups of flour. You need to be able to figure out how much of each to use, even if you're not using the exact amounts. All right, so the first thing we're going to do with these proportions, or with the ratios, is we're going to figure out if they are proportional to each other. So we're going to get 2 ratios, and we're going to see if those ratios are equal to each other. All right, so 2 ratios are proportional if what? What did I do to see if they were proportional?
By each other. If they can go in.
All right, so 2 ratios are proportional if they are equal when we do what to them?
Reduce.
When they're reduced. So if we reduce both fractions and they're equal to each other, then we know that those 2 fractions are proportional. We're going to do a couple examples here to check to see if we have a proportion or not. So we have 2 fractions. If they are proportional, that means that the fractions are going to be equal to each other. So we need to see if they're equal to each other. What am I going to do?
You have to reduce.
Reduce them. Can I reduce the 3/4?
Yes. No.
No. I'm just going to copy that down since I can't reduce it. Can I reduce the 6 over 8?
Yes. By 2.
By 2, okay. 6 divided by 2 is?
3.
3. 8 divided by 2 is? 4. Are they equal to each other?
They are.
Yeah, so we didn't reduce the first one. We had to reduce the second one, but when we do, they're equal to each other, so we're just going to say yes. All right, so the question is, are they proportional? Yes, they are. Here's the next one. Now, just to help you out with your work, go ahead and write the problem down, but then underneath it, what I would do is write both of the fractions like this, and then just reduce going across, and see if you get the same thing for both. Reducing both of them completely, we get 5 over 11 and 3 over 5. Are they proportional?
No.
No. So these 2 fractions are not equal to each other. They might be kind of close, but they're not equal, so not proportional. No would be a good enough answer there. All right, now, more of the problems that we're going to see, we're actually going to have to solve a proportion, meaning that we're going to be given a fraction and another fraction, but one of them is going to be missing something. We're not going to know everything about the problem. We saw problems like this last week when we did the proportion word problems with the percents, where we knew 3 things and we needed to find the 4th. All right, so if we have a proportion that has something missing from it, how do we solve for that missing thing? How do we solve for that variable?
1. Put a 1 in.
So in order to solve a proportion, we're going to cross multiply. And then once we cross multiply, we won't be done, at least probably not. The other thing we'll have to do is we'll have to solve for the variable then. So cross multiply then solve for the variable. And keep in mind when we're solving, we've got some rules about how we solve equations, right? We have to set it up by circling the variable, drawing the line of equality, and then we want to get that variable by itself. So here's example 3. We have a proportion. It's a proportion because we have a ratio equal to a ratio, but it has this variable in it. We want to figure out what a equals to make this true. All right, so what are we going to do? So when we cross multiply, does it matter if I do 2 times 6 first or 3 times a first? No, it doesn't matter. I always like to do the one with the variable first, just to have the variable on the left side of the equation. So we do 3 times a and get 3a. And then on the other side, we do 2 times 6 and get 12. Would it be okay if I wrote instead of 3a, a3? No. Whenever we have a variable and a coefficient or a number that we're multiplying by the variable, we always want the number first. All right, now we want to get a by itself, so what do I do?
Divide by 3.
How about circle the variable and draw the line first?
Yeah, that's cool.
So we circle the variable because we want to get that a by itself. We draw the line of equality and then divide by 3 on each side. We divide by 3 on the left to cancel out the 3, leaves the a. We divide by 3 on the right because whatever we do on one side we have to do on the other. And we get 4. And so a equals 4. All right, example 4 is pretty similar. Go ahead and try this one on your own. So we'll start by cross multiplying. C times 24 is 24c. 20 times 12 is 240, and we put an equal sign between them, and then what? So we'll divide on both sides by 24. 24's cancel, that leaves c, and on the right side, 240 divided by 24 is? Alright, this one's a little different. What's different about this one? Yeah, there's 2 terms in the denominator on one side, right? So the 2/3 on the left side, that's fine. But over on the right side, we have 6 over b plus 5. So these 2 terms here are going to affect what we do. I'll get you started here. We can't just put them together because b plus 5 is not the same thing as b times 5. If we just put them together, that'd be multiplying, right? So what we need to do when we cross multiply here, and we do this 2 times b plus 5, we're multiplying the 2 times the whole thing. So we do 2 times b and get 2b, but we also need to do 2 times 5 to get 10. So it's going to be 2b plus 10 on that side. And then we also cross multiply here, denominator times numerator, there gives us 18. What are we going to get rid of first here to get that b by itself?
Plus 10.
All right, and how do we get rid of the plus 10?
Subtract 10.
Okay. So take 10 away on both sides. On the left side, they're going to cancel out, right?
Yeah.
So the 10s cancel, leaves 2b equals 8. And then what?
Then you gotta divide by 2.
Divide by 2 to get rid of the 2 in front of the b. And when the 2's cancel there, we get
you put a 6
b.
over there.
That's weird. I think that's a b. It should be a 2. Thanks. So we get b equals 4.
4.
Whew, that was going to be awkward. One more. Now I want you to notice on this last one here, there's a little bit of extra directions. What does it say?
Round to the nearest thousand.
What do you think is going to happen?
It's going to be a decimal.
Yeah, we're going to get a decimal answer. So you guys can solve this. Go ahead and solve it. But then when you get to your answer, we're not going to leave it as a fraction, but we're going to write it as a decimal. And since it's going to be a decimal, we're going to round to the nearest thousand. It's going to be one of those big long ones. All right, so we cross multiply here. D times 7 is?
D7. 7D.
What do we get? David?
70.
Okay, and then when we multiply the other way, 6 times 5 is? 30. All right, now we need to solve for D. So before we start getting rid of things, what do we need to do?
You gotta circle the D. Try your line of equality.
Then what?
So divide 30 by 7 on both sides.
Okay, divide by 7 on both sides. That's going to cancel out the 7 on the left. And on the right side, before, we would see this fraction here, and 7 doesn't go into 30, so we would just leave it as a fraction, make sure it's simplified, and be done. All right, but now for the problems that we're going to be doing these proportions with, it's going to be more useful to know what the number is, what we actually get when we divide 30 by 7. So we're going to divide it and get what, David?
Decimal.
Four-
4.2857.
Okay, and then, yeah, it is going to keep going. It's going to repeat. So after that, 2 is going to be an 8, 5, 7, 1, 4, 2, 8, 5, 7, and so on. But we need to cut this off, right? So it is useful for us to know what we actually get when we divide it, but we can't keep writing this forever. So we're going to round to the thousandths place. And first thing we need to do that is figure out what the thousandths place is, which would be what, David? The 5. So we get rid of everything after that. And then we have to decide if this 5 is going to stay a 5 or if it was really closer to a 6 and we need to bump it up. What do you think, David?
It goes up
Why is it going to bump up?
because it's above 5.
What's above 5?
That's it.
The 7. So we look at the next number, the first number that we got rid of, and that's 5 or more, meaning that the 5 here was really closer to 6, so we get D equals 4.286. Make sure that when you write your answer, you write it as an equation. Remember, when you solve an equation, you get an equation as your answer. D equals something.